All right, our last SIG test topic, topic 43, absolute value equations. First, we want to be able to write the equation of an absolute value. The general form we need to know is y equals a times the absolute value x minus h plus k. So if you notice, this looks very similar to our graphing form of a parabola, just has absolute values instead of the squared. All right, so h and k are still going to represent our vertex. So we want to start there. Remember, opposite h, same k. And so we go to this first problem, find our vertex, which looks like it's at 3, 4. And I'm going to write y equals absolute value x minus 3 plus 4. Remember, opposite h, same k. Now with parabolas, we actually had to do a lot of work to find our a value. Absolute values are a lot easier because these slopes are always constant. So we simply just check the rise over run. You're just going to use a slope triangle from one point to the other. Looks like we're going down 2 over 2. Or sorry, down 4 over 2. So the slope would be 4 halves, or 2. Now notice I get a negative 2 slope and a positive 2 slope here. Well, if the absolute value is upside down, a is always going to be negative. If the absolute value is facing up, a is always going to be positive. So the slope here is, actually we have a negative 2 and a positive 2, but it's upside down, so we put for a, negative 2. It's that easy. Okay. Little less work than the parabolas. Okay, so we have 1, 2, 3, down 1, 2, 3, 4, 5, 6. So the vertex is at 3, negative 6. So I first start with that. We're going to have x minus 3 minus 6. Opposite h, same k. And then a, notice we have an absolute value is facing up, opening upward, so a is going to be positive. Just check the slope. Rise over run, up 3 over 1, up 3 over 1. My slope is 3, so a is going to be a positive 3. And we're finished. Okay, one more. Vertex is at 2, 3. So we have y equals x minus 2 in the absolute values plus 3. Again, opposite h, same k. A should be negative because the absolute value is opening downward. Check the slope. Down 1 over 1, 2, 3, 4. So we have a negative 1/4 for my a value. All right, so you guys want to try these 3 problems. Pause the video. All right, and check your answers with these 3. All right, and this SIG test topic actually has another part to it. The second part is actually solving absolute value equations, which you actually did in Integrated 1, so this should be review. So remember, our first step is to isolate the absolute values. So we get this by itself, which is already done in this problem. Once we have that done, we write 2 equations dropping the absolute values. So I'm going to write this expression inside, 2x plus 5 equals 3, and it has to equal negative 3. You need to solve both of these equations. And then it just comes down to solving these 2 linear equations. And you should get 2 solutions. Always check that they work. Okay, so 2 answers for x will work in this equation. All right, now number 2 is no solution because if you recall, any number that I plug in for x here, it doesn't matter. The absolute value is always going to change this to be positive. So once I have this absolute value isolated, this number cannot be negative. This must be positive. Okay, if you get this isolated, and you get a negative number, stop and just say no solution, you're done. Okay, we'll do 2 more with you. Number 3, notice the first step is not done on this one. We first have to get the absolute value by itself. So we're going to subtract 8, getting x minus 6 equals 7. Then drop the absolute values, write 2 equations where x minus 6 equals 7 and x minus 6 equals negative 7. That will give you 2 solutions, x equals 13 and negative 1. Okay. And the last example here, get the absolute value by itself, divide by 3. So we're going to have 5 minus x equals 7. This is a positive number, so we continue. This expression inside has to equal either a positive 7 or negative 7. Solve both of the equations, and you should get x equals 2, negative 2, and positive 12. All right, so pause the video and try these 4 on your own. All right, and check your solutions. All right, and I hope this helped.